Today's lesson is about proving statements about segments. Okay, so let's start out with a proof is a logical argument that uses deductive reasoning to show a statement is true. And in math, true is 100% of the time. Example 1. Given point T is the midpoint of segment SU, prove that X equals 5. All right, when we're writing proofs, there are two parts of what we're doing. So we have two columns. One column is called a statements column, and one column is called a reasons column. So when I start out here, I have information that's given to me, and I'm trying to prove something. So the information that's given always goes as the first reason. So the first reason is always given. And the statement that's given, T is the midpoint of segment SU, is the first statement. So given is the first reason, and the information given is always the first statement. And then what I'm trying to prove, this is what I'm doing. I am trying to prove that X equals 5. So whatever I'm trying to prove is always my last statement. Okay, so now we're going to keep going through, and we're going to fill in the rest of the math and the rest of the reasons. Okay, so this is a visual of our situation here, that T is the midpoint of segment SU. So we're going to start out with and say that segment ST is congruent to segment TU. And that I can say because of the definition of midpoint. And this is geometry. When I'm talking about the shapes and saying congruent, I'm talking about geometry. So I'm going to switch into algebra. So algebra is distance. So I do not have the segment symbol, and now I'm saying equal. So the distance from point S to T is equal to the distance from T to U. And that is the definition of congruent segments. Next, I'm going to take my information here. So these are my two congruent segments. And I'm going to substitute. So I'm going to substitute 7x for S to T and 3x plus 20 for T to U. So I'm doing substitution. Next, I am looking at what am I going to do to solve for the variable. So I'm going to subtract 3x from both sides. And whatever I'm doing to go from here to here is what I write in the next box. So this is my subtraction property of equality. So subtracting, I have 4x equals 20. So to go from step 5 to step 6 is what I write in for reason 6. So 4x. So next I want to divide by the coefficient next to the variable. So my next step is division property of equality. And we are done. Okay, so we have 3 more properties. And those properties are reflexive property. This I use and I say, this is like looking in a mirror. It's kind of what I say is you equal yourself. So that's kind of what I look like, is that I'm thinking of a mirror. So if I'm talking about segments, of which right now we're just talking about segments, segment AB always is congruent to segment AB. Symmetric means I'm in a flip. So whatever I have on the left side of the equation is now on the right side, and what's on the right side is the left side. So I'm just switching left and right sides. Transitive means that if I have segment AB is congruent to segment CD, and then I repeat, segment CD is congruent to segment EF, I can just go from the first to the third and say from 1 to 3. So I can say segment AB is congruent to segment EF. All right, so let me check. Do we understand reflexive, symmetric, and transitive? Let's do an example here. All right, the first one is using angles, and we haven't quite covered that yet, but I think we can still understand the concept. So if I'm saying angle T is congruent to angle V, and angle V is congruent to angle R, then angle T is congruent to angle R. So I'm seeing a 1 to a 2, 2 to a 3, and a 1 to 3. So we call that the transitive property. And if segment JL is congruent to segment YZ, then segment YZ is congruent to segment JL. So these are just switching or flipping, so we call that symmetric. All right, let's try another example with a proof. This time I didn't fill in any of the parts for you, but I know at least 3 parts I can always fill in. So let's start out with, this one's asking me, given that segment LM is congruent to segment NP, and I'm showing that with tick marks on my segments, I want to prove that segment NP is congruent to segment LM. So when we're writing our proofs, I always start out with whatever's given. I always write given as my first reason. Next, the information I'm given, I write in my first statement. So segment LM is congruent to segment NP. And then I am trying to prove, this is what I'm doing. I never say the word prove as a reason. This is what I'm doing. So I'm trying to prove that segment NP is congruent to segment LM. So this is what I'm trying to do. All right, so let's start working through. So the first thing I want to do is I want to switch from, this is in geometry, and I want to switch to algebra. So here I'm talking about shapes in statement number 1, and now I want to talk about distance. So L to M, the distance from L to M is equal to the distance from N to P. And this is the definition of congruent segments. Okay. And now I'm going to just switch the order of what's on the left side of the equation and what's on the right side. So I'm going to say the distance from N to P is equal to the distance from L to M. And when I switch the left-hand side, I say that's the symmetric property of equality. And then I'm going to switch from algebra back to geometry. So I'm going to go from distance to shapes. And again, that's definition of congruent segments. Okay, that one was a pretty easy one. Let's try one that's a little bit more complicated. If you know that M is the midpoint of segment AB, prove that AB is 2 times the distance from A to M, and A to M is 1/2 the distance from A to B. Okay, so we're saying M is the midpoint, so let's just get a visual of this so I know these two congruents are, or these two segments are congruent. So I always start with given. So I know the first reason is always going to be given. And what I have given is my first statement. So my first statement is M is the midpoint of segment AB. This goes to my first statement. M is the midpoint of segment AB. And I am trying to prove, this is what I'm doing. I'm trying to prove two things. I'm trying to prove that 2AM, so I have to put each thing in its own statement. So 2AM equals AB. And I'm trying to prove that AM is half of AB. So I put one statement per line. I never use the word prove as a reason. That is what I'm doing. All right, so let's start filling these in. Okay, so since I know M is the midpoint, I know that the distance from A to M, or the segment AM, is congruent to segment MB. And I know this because of the definition of midpoint. Now, this is in geometry. We're talking about a shape. So I want to switch that to algebra. We're talking about distance and numbers. So the distance from A to M is equal to the distance from M to B. And that's the definition of congruent segments. Now, I know that I can say, I can use the segment addition postulate and say A to M plus M to B equals A to B. And I can say that from the segment addition postulate. Now, I know that AM and MB are congruent. So I'm going to substitute AM where I have MB here. So now I have AM plus AM equals AB. And I did that because of I can substitute. So now I have AM plus AM equals AB. So when I add these two together, they become 2AM. So I am doing the addition property of equality. And if to go from here to here, if I divide both sides by 2, I get AM equals half of AB. So that would be, I'm dividing, so division property of equality. Okay, and that's the end of the lesson.